Good morning, girls. Today's lesson is chapter 7, lesson 6, choosing a factoring method, and we're going to finish the lesson by doing example 3. Now, example 3 is kind of similar to example 2. In example 2, we use two ways of factoring an expression. So in example 3, we're still going to do the same way or same technique, which is using many different thinking about different methods of factoring. But sometimes we're going to start with a method different than GCF. Sometimes you will see that none of the methods will work. Sometimes we will be needing 3 methods of factoring. So let's start with the example and see how is it going to work. For example, if I gave you 2x power 2 plus 5x plus 4. Okay, first you would think about factoring by GCF, so taking common factor. But if you see, there's nothing common between the 3 of them. I have here 2 and here 4, but there's nothing here 2 or 4. Here I have x, but there's no x here. So factoring by GCF will not work. The second method that I would think about is the one that looks like ax power 2 plus bx plus c. And you remember we need two numbers. If you multiply them, it's ac. If you add them, it's b. So let's try this method. We need to find two numbers. If you multiply them, it will be 2 times 8, 2 times 4, which is 8. And if I added them, it will be 5. So I will think about 1 and 8. But if I added them, they're not 5. So 1 and 8 won't work. Let's think about other numbers. For example, 2 or 4. But if I added them, also it will not work. Even if I put any negative signs, if you think about it, it will not work. So this way will not work. Okay? If you think about other factoring methods, for example, perfect square, it won't work because, okay, 4 you can make it 2 power 2, but here I have, okay, x power 2, but 2 you cannot make it something with the power 2. So I just look at this, there is nothing can work here. And you would say that this is cannot be factorable. Not factorable. That's how we solve this or find or factor it. I simply can't. Now let's try another example. 3 and 4 minus 15 and 3 plus 12 and power 2. First thing I would think about, and this is what the first thing you should always think, is factoring by GCF. So do I have common between the 3 of them? Obviously there is. So let's factor this. 3 times 5 with 3 ends plus 3 times 4 with 2 ends. The common is 3, and I have n, and I have another n. So like n power 2. That's it. I cannot take anything else. Here I have n times n, which is n power 2, minus 5n plus 4. Now here, can I do anything else here? This would remind me with finding by x squared plus bx plus c. You have to find two numbers that will give you c, and if you add them, it will give you b. So let's try it here. I need two numbers that will give me, if I multiply them, it will be 4. And if I added them, it will be negative 5. So 4, I would think about 1 times 4. but if I added them, it will be 5. I need -5, so let me put a negative for the numbers. Now it works. -1 times -4 is 4, which is correct. -1 and -4 is -5 if I added them, which is correct. So here you can simply write it as n minus 5 and n plus 4. The other number is 4. And don't forget to put the 3n power 2. And that's it. You cannot continue. You cannot do anything else. So this is the final answer. I think this is a good way to revise all the lessons, like doing this example. What if we have 4x power 3 plus 18x power 2 plus 20x? GCF, it works because I can see 4 or 2 may be common and x is common. So let's do it. This is 2 times 2, x power 3, which is 3x's. Plus 18 is 2 times 9 with 2 x's, and 20 is 4 times 5, which is 2 times 2 times 5 with 1 x. The common is 2 and x. That's it. So what's left is 2x power 2, 9x, and 10. 2 times 5, 10. Now this one, how can I do this one? It directly reminds me with this method. You need to find two numbers. If you multiply them, it will give you AC, which is 2 times 10, which is 20. And if you add them, it will give you B, which is 9. So 20, which is 4 times 5, I think it works. 4 times 5 is 20, and 4 plus 5 is 9. That's correct. Now, do you remember here we separate the 9x into 4x plus 5x, because I got here 4 and 5. And I have here plus 10. Now you take the common between the first two, which is, let me do it step by step. Here 2xx plus 2 times 2x. And here it's 5x plus 2 times 5. So the common between these is 2 and x. So 2x into x plus 2 is what is left. Now here I have only 5 common, and what is left is x plus 2. You can obviously see that x plus 2 is common, so you put it here, and 2x plus 5, you keep it alone. And also you cannot continue. Now the third or the fourth one in this example is fourth expression is P5 minus P. Now it's easy, you can see that P is common. P into P5 is, if you take the common from it, then it will be P4 minus 1. Because it's 5 P's, I took one of them, and so only 4 are left. Now P4 minus 1, this would remind me with the difference of two squares. Let me continue here. You have P into P4 minus 1. Difference of two squares says that a squared minus b squared equal first minus second and first plus second. So p4 you can write it as 2 power 2, all of it to the power of 2, minus 1 to the power of 2, and it will be first plus second, first minus second. This is the difference of two square method. Now this one, there's nothing common you can take, you cannot continue in any way, so this is done. P is done. I'm just checking each one of them that it's it's completely factored. This one, p squared minus 1, is also the difference of two squares. So it will be p minus 1, p plus 1. This doesn't apply here because it only applies when there is a minus, but with a plus it doesn't work. And this is the final answer. You cannot factor anymore. I know it might seem a little bit hard because now it's the combination of 5 lessons all together, but within practice it will be easier for you.